Okay, in this video we're going to talk about a factorial analysis of variance. And remember, we have more than one independent variable. So in this case it's a 3 by 2 factorial because one of our IVs is alcohol. And let's suppose that we have a control group that gets no alcohol level, different group that consumes enough alcohol to get up to 0.05 BAC, and another group that consumes enough alcohol to get up to 0.1 BAC. And this is between subjects manipulation, different groups of subjects. But now we have a second independent variable. Oh, and we're expecting that alcohol is going to affect how many words people can remember from a word list. So it's a simple memory test. We also think exposure duration, that is how long the word is exposed while they're studying it, either short or long, will also affect memory as well. For its short exposure, we're only showing it for 0.2 of a second, 200 milliseconds, or we're showing it for 1 full second in the long exposure condition. So here you can see, just I set it up like I did before. So subjects 1 through 5 are in this group, 6 through 10 are in this group, 11 through 15 are here, 16 through 20, 21 through, and the dependent variable is the percentage of words recalled from the list. So let's look at, so this is the design, there's the data. So let's look at the source table and how it's going to be similar and different to the other things that we've seen before. So we have two independent variables. We have a factor A, right, which represents alcohol. The degrees of freedom are going to be A, or the number of groups of factor A, right? So we had 3, so it's 3 minus 1, right? And you'll see down there it's 2. We have a sum of squares for A. We have a mean square, which is sum of squares divided by the degrees of freedom, right? We have the same thing for B now, but it's B number of levels. So we had 2 levels here. So it's 2 minus 1, or 1, right? We also have a sum of squares. We also have a mean square. Okay. Now we're also going to have an interaction, and the interaction is represents the combination, how the combination of variables affects behavior. And this is something we'll explore in detail in class. But there's the degrees of freedom. It's just these two multiplied by each other. We have a sum of squares for that, and the mean square is sum of squares divided by the degrees of freedom. We also have the error term. And the error term is really not any different from the one-way analysis of variance. It's whatever's left over, the residual, the error term, whatever's unaccounted for, and of course we have a total sum of squares as well. What's a little trickier, a little different, is we have now 3 F's, right? Before we only had 1 F. Now we have 3, because we have 1 for our first independent variable. Does alcohol affect memory separately and by itself? Yes or no? And we'll be able to test that. Does exposure affect memory by itself? Yes or no? And we get this value by collapsing or ignoring the other IV. So if we want to know how does alcohol affect behavior, we collapse across this other variable. So this all gets treated as one big group here. This all gets treated as one big group, and this all gets treated as one big group. And that's we'll talk more in depth about that in class. But we get the third F for our interaction. And each one is tested to see if it's significant, because they're all independent of one another. So here's the Spss output for that. And as you can see, alcohol affected memory, right? It's less than 0.05. So that's significant. Exposure is significant, right? But the interaction is not significant. So we have 2 main effects, but our interaction is not significant in this analysis for a factorial analysis.